Okay, so now I'm going to move on to UST systems installed on or after July 1st, 2004. So these are famously known as your VPH tanks. Okay, you guys familiar with that term? I know we just call them VPH. We know what that means. We know it's the post 2004 tanks. It's going to have the continuous monitoring. So that's our nickname. But so the issue here, and don't forget these are pretty much, if you're putting a tank in now, these are the requirements that you're going to be following. So these tanks must be designed in construction with a continuous monitoring system, okay? And the capabilities must include detecting entry of the liquid or vapor phase of the substance stored in the primary containment. Obviously, you're going to notice that in the secondary. And then also, you must be able to detect water intrusion into the secondary containment. And we'll get into that detail a little bit later. So, you know, you see the terms continuous monitoring, and you might ask, well, haven't you needed continuous monitoring since 1987 or 1984 for tanks, because you need that monitoring for the double-walled components. But the issue is the requirements call for continuous monitoring via constant vacuum, pressure, or the use of interstitial liquid level measurements, otherwise known as hydrostatic. You might notice, although the hydrostatic is included in this post 04, this hydrostatic portion has been an option for tanks installed since, 84. Because when we talked about the fiberglass tanks, that was always an option, was to have a wet annular space. So that's nothing new. It's more the options of the vacuum or the pressure. So like I said, we have the VPH acronym, and we just use that interchangeably with post-2004. That gets a little wordy. So V, vacuum, is below atmospheric pressure. P for pressure is going to be above operating pressure. And typical operating pressure is anywhere between 28 and 32 psi. Hydrostatic, of course, we're looking at our interstitial liquid level monitoring. So regarding tanks, oftentimes hydrostatic is very common. Like I said, that's not a new technology. Low-level vacuum is also popular for fiberglass tanks. Okay, and then low-level or mid-level vacuum is also most popular for steel tanks. You're not going to have that hydrostatic option. Okay, and of course, your vacuum levels, you should always refer back to your manufacturer's recommendations, because there are limits to these components. Piping, we have low-level vacuum is, I would say, the most popular option. However, pressure and hydrostatic monitoring methods can be utilized, but you always want to make sure you're using the right components with the correct option, and I'll address that in just a minute. San Diego, we really only have one station. Actually, it's not even a station, it's a non-retail facility that has the hydrostatic monitoring option as part of the piping. They have fiberglass pipe. You mostly see the low-level vacuum for the piping, and then for sumps and UDCs, we often see vacuum or hydrostatic similar to the tanks. So this is a non-metallic piping matrix, and it was put together by the state. It's a matrix of all the different non-metallic piping types and the type of monitoring applications that they've been approved for. And this is not part of your handouts, but this can be found also on the state website. So I was talking about the example of this list, the various brands. Keep in mind this is just non-metallic options. And then this column here shows the different options that have been approved for the closed loop system, meaning the continuous monitoring systems. And you notice most of them are only approved for vacuum or pressure, but you do have one or two approved for hydrostatic monitoring. And this one notably is one of the Amron products, and they've been approved for that hydrostatic as well. And that's the actual piping we saw in San Diego that had the hydrostatic monitoring. Like I said, we've only, other than this one site, we see the vacuum. So this is also part of your form. You guys might want to reference this, but it gives you 3 different options. And these options, it can sometimes be difficult to describe. So if you have any questions, just please let me know. So don't forget the basis for this requirement is that you need to have the continuous monitoring, whether it be vacuum pressure or hydrostatic monitoring. So how do you achieve that? Option number 1, I'll read it here, then I'll try and just give you a summary and make it more understandable. But for option number 1, the entire piping length, okay, visualize that, the entire length, including the piping within the sumps, UDCs, must be monitored using vacuum pressure interstitial liquid level measurements. So you guys can picture a typical scenario where you have your underground, your buried piping that's double-walled, and then oftentimes, once it comes into the sump, it transitions to a single wall line, which attaches to the STP, or turbine rather. So with option number 1, the entire line needs to be double-walled. So you're looking at the bottom of the shear valve all the way to the turbine, and you most likely have to encapsulate the turbine. Any of you guys have sites that have option 1 as their monitoring? Can you guys visualize that? I mean, the entire thing needs to be double wall. There's not a single wall transition piping anywhere along the runs. Okay. In addition, you need to have the UDCs and the sumps will still require 208 sensors. And you also need a line leak detector. So we'll just get that out of the way. Everyone still needs a line leak detector. That has not changed, okay? So option 2, you know, option 1 sounded kind of kooky, but option 2 is even more kooky. You're going to have your buried pipe that's secondarily contained, as it has been since 1987. And you're still going to have your primary containment, for example, your single wall transition sump, or your fill piping, and you're still going to have your secondary containment that we're used to seeing, such as a sump or UDC. However, so you have your options of vacuum, pressure, or hydrostatic. What's the reality that you could pull a vacuum on the entire sump without a leak, or put pressure on an entire sump, or for that matter, fill an entire sump with water and monitor that? So that doesn't make too much sense either. But you don't need sensors in the sumps or UDCs if you have this option, because that space is being continuously monitored. Option 3, this is the only option I've ever seen. Have you guys, any of you seen option 2 in your districts? No? So option 3, you have your single wall transition pipe or your fill pipe, your single wall fill pipe that must be contained within a double walled sump. So now your outer components are going to have the actual double wall, and their interstice will be monitored under vacuum pressure or hydrostatic test or monitoring. Okay? So during a tank inspection, it's going to look very similar to what it looks like now. You're going to see your primary transition pipe. You're going to see your double wall piping. The only difference you might see is that what we call a test boot is going to be permanently on because it needs to maintain that closed loop. Okay? So you're looking at a double wall UDC or a double walled sump that will contain any of that single wall transition. So therefore, you're meeting the requirements of this section. And then, of course, with this option, you're still required to have your sensors in your sumps and UDCs, and you're also still looking at that 3.0 gallon per hour line leak detector. Okay? Also note, annual line tight tests on pressurized piping will no longer be required for systems installed on or after July 1st, 2004. So you don't need to do that point 1, which was part of that original monitoring that most people don't do anyway because they were doing pump shut-off and fail safe. So bringing it back full circle. So here's a nice close-up of a double wall sump. We have your interstices, and they're very small. Not sure what brand this is. This might be Bravo, but that's just a nice field picture showing a close-up of how a double wall sump might look. Okay, so I'm going to go ahead and talk a little bit about the particulars of vacuum or pressure monitoring system. So I'm not sure how familiar you guys are with these sites, but these sites also are monitored with zones. So you're going to have your vacuum sensors that will monitor only a portion of the secondary part of your system. And I'd say on average you have anywhere from 7 to 10 zones. And I'll show you, next slide shows that example of a zone. So you're only, each sensor, each vacuum sensor or pressure sensor is really only capturing a small portion of your system. Okay, so you want to maintain that pressure or vacuum of each zone. That's how you're going to tell if you have a leak or not. And the set points for those zones have been established by the manufacturer. Of course, when that pressure or vacuum varies above or below those set points, it's going to go into alarm. And you're going to see a typical alarm on the monitor would be an S alarm. Okay? And there's often an integrated pressure vacuum source to compensate for fluctuations in pressure. And in most cases, that's going to be the turbine. That's going to be the supply for that source. And then most systems also include a liquid sensor. And that's going to detect, if you go back to our previous slides, one of the requirements that it would detect water intrusion into that secondary. And I'll show you the types of sensors that would be responsible for catching that. Okay, and then of course, you want your third-party approval limits for the interstitial volume. LG1, the question was, can you elaborate on the volume? I can't hear you either.
My question was on LG113, the interstitial volume. How much interstitial volume is too much for the smart sensor? What's the third-party rate for the smart sensor? Is it possible to have all the interstitial on one smart sensor, or where's the delineation?
I don't know the exact delineation, but typically we see, like for a 2 to 3 tank site, there's about 7 to 10 zones. And the next example I'll show you now. Often you have this example shows an 87 fill sump, and that yellow piping, it's hard to see from back here, I see now, but you can see those connector piping, and this is one example of one zone. So in this case, you have your interstice from your fill sump, and then you can't read it there, but this is the vent line. So you might, on this particular zone, whether it's configuration based on 113 or manufacturer, or just the ease of creating this system at this particular location, and I'm sure there's lots of different variables, but this zone will only so this example is a zone that will only monitor the 87 fill sump, interstice, and this is the vapor recovery line. So this is typical, 1, 2, or 3 components of one grade that might be under one zone. Like I said, I don't know the exact limitations based on 113, and I didn't bring that reference with me because it's about that thick, but you can look it up online, but I've never seen a single zone for a typical retail site. But yeah, your components will determine how many zones you have. And here's just another field picture of of potential zones. I'm not sure how they're connected in this scenario, how many zones there are, but this is more of an example to show you how these tubings provide either the vacuum or the pressure source. So it's hooked into these secondary lines. And this is a view of a UDC. And here's some examples of what the vacuum sensors look at. Here's obviously a Veeder-Root brand. So you're going to have one sensor per zone. And like I said, each zone has 1, 2, or 3 or so components. And the programming, your Veeder-Root printout should be able to tell you what components are monitored under each vacuum sensor. So here's a close-up. Here's a typical setup of how you might find them in the sump, a section of 4. And this one has some labels. And what you also find, just looking at these labels, it looks like you can have one sensor per one component. So this label has Supreme Fill. This one right here has Supreme Turbine. And this one covers all vents. So there's all sorts of combinations you can have. I imagine it depends on the setup of the station, the layout of the piping in the tanks, and the limitations per LG 113. And I mentioned before that you need to have some sort of sensor that's going to catch any sort of water intrusion into that secondary space. And here's an example, this red circle down here. They're called cup sensors. And these sensors are placed within that vacuum line before you get to the vacuum sensor, and it will detect the presence of water. And these are typical float sensors, similar to a 208. And then here's another example of how, the vacuum sensors are placed on this board, and it looks like someone's taking some effort to put them on a board that can be easily lifted in and out of the sumps for the monitoring certification. I know some companies fix it up real nice. It has a handle, a little tripod. They pull it out and they can place it on the tank top and be able to work with the sensors. Okay, so now I'll just touch upon quickly the hydrostatic monitoring system requirements. Of course, not really different than it has been since 1987. You're still going to be maintaining a fluid level in the interstitial space, the reservoir. And you have high and low set points, and it's going to alarm if you go too high or too low. And those set points are established by the manufacturer. You're going to need third-party approval required for tanks and piping. And then, of course, third-party approval listing for the sensors. And all those items are also found in LG 113. And just so you know, I do post a link for the LG section of State Water Board for reference at the end of the presentation. So here's just some additional pictures showing hydrostatically monitored sump. This green, I know it's hard to see in the back, but this green area represents the fluid in the interstice. And as you remember from that earlier picture, it's a very small space. And then this is where you're going to have your sensor right at the top. Well, this isn't working very well. So right at the top, you see that reservoir. So it's almost like a mini reservoir that you would find on a tank. It's going to register any sort of drop or increase within this interstice, the same as it would with a hydrostatic monitored tank. Here's another example of a UDC, and their reservoir is a little bit more substantial, but it's the same idea. There's high and low set points where that sensor is going to sit, and it will detect a loss or a gain in fluid. Last example, Environ pipe here. You can see that yellow line going down the middle is going to be the sump wall interstice, and that just represents the fluid there in between. Okay, so of course, as with any system, you're going to have startup requirements. And part of it, just like pre-2004, you're going to run through that final inspection, and you're going to do functional testing. So it's nothing too new. You're still going to do functional testing of your typical 208, some sensors, but you're also adding to that. You're doing your functional testing of either your vacuum sensors or your additional hydrostatic sensors, depending on the type of continuous monitoring that you've picked. For vacuum pressure, you're going to induce a simulated leak in each zone. You're going to verify alarm and pump shutdown, if applicable. You know, going back to one of the first slides, we talked about being, you know, stringency of state law versus federal versus county. It's not required to have pump shutdown, if you remember that, but we do require at a local level that any zone associated with product piping does have shutdown. So that's an example of being more stringent than the state. And then, of course, after you do your simulated leak, you want to make sure that you bring that vacuum or pressure back to, I guess, the comfort level, the all functions normal setting, you know, within those set points so that it's not an alarm. And then, of course, you want to verify interstitial communication. Every once in a while, you see a scenario where they might verify the alarm when you simulate a leak, but really they've just simulated a leak in a 3-foot section, so you're not actually testing the entire piping run. So how can you verify that? And a couple options. You can also induce a leak at a UDC as opposed to a sump, which is more common. You can install gauges at far end of the piping runs to see if they go down. I've not seen this before, but I guess an option would be tamper evidence seals on vacuum line valves to make sure maybe after your startup inspection the system's not modified. Okay, pop quiz. But I think I'm off the hook for a while. Give rest up. So what are 3 methods for continuous monitoring? VPH. Yes. So here's a scenario. You have a UST system with 3 tanks and associated piping and UDCs, and this system was installed in 2001. If they repipe the entire system tomorrow, anytime in 2012, will the new piping require VPH monitoring? No? Why not? It's new, right? Right, tank's not new. So VPH comes into effect when you're installing the tank. You can change out the piping, you can make your modifications, but it becomes the monitoring requirement when that new tank is installed. Okay? Oh, this is not really a break. Yes, Amy. The question is, field inspectors, just before I move on, how many of you guys have done inspections with these types of systems or are familiar with these systems? So I'll ask her question to you guys. Her question is, do you find that it takes a long time to bring the vacuum source back up to speed where it should be? Is that right? Do you guys find it takes a long time? Yeah, so that's about average. That's what we found. A little faster for some of the smaller sites, like our 2-tank 7-Elevens, but we average about anywhere from 15 to 25 minutes. So definitely these new requirements have added time to our inspections. Just more components, more paperwork, more components that take longer. So, good question. Anything else before we move on? So we're not going to take a break right now since we did move things around because of launch. And thanks for being flexible with everything. This is the first time we presented this, and it's supposed to be an 8-hour class, so we're trying to find our way here. But so we're going to move on to testing requirements, and we will have a break before we get to the end. And luckily, I was able to obtain a PowerPoint presentation. Got it from my boss over lunch. And if you guys want, we can just to get some more time on the books. I know some of you are here for ICC hours, but we will have an official end to this presentation. But I also have another PowerPoint we can go through if you want more hours or just for ICC. It will give you some helpful hints for the ICC exam, because it seems like a lot of you would be interested in something like that. So just keep that in mind.